Okay. I'm going to release some instruction for you to submit your projects, which will be due next Tuesday. Okay, work on that. And review session, if you guys need it. I think I'm going to start making the exam over the weekend. So I can talk maybe more about it, maybe on Tuesday. Maybe give you guys a little bit more tips about how you should really study. But don't wait for me. You should really definitely get started going over the material. It's next Saturday. It's not very far away. Okay. And I just wonder, I already submitted some requests to the department about some lecture hall. We can make it in person. I'll try to record it as well. So do you think you guys can make it to Thursday, December 8th? Afternoon? Okay. Would be okay, right? Okay. So, okay, good. And I'm going to confirm the time. Okay. Okay. Of course, if nobody show up, then nothing to review, right? Okay, good. Okay, I'll confirm with you the time. Okay, so today we're going to, this will be the second last lecture for the course, of course. And I'm going to divide the remaining material again into half. Today we're going to cover something, and then on Tuesday, in the first hour or less, we're going to finish all the materials. And then, as I promised, I want to show you a little bit about what people did for their project in the last iteration of the course. If you guys are interested in doing some side projects, you can go ahead. That's what I will do. Okay. Let me now do some very quick recap so we can continue with what we covered last time. The main thing that we introduced on Tuesday, let's recall very quickly, we definitely need this concept today. We introduced the idea about LR1 item, right, for bottom-up parsing. And this will be the syntax that you should really know, right? That's something we discussed thoroughly on Tuesday. We only discussed about how you can, understand the individual components' meaning and how you can enumerate about the possible items. Today, we're going to see how we can, let's say, given a particular grammar, if we want to do bottom-up parsing, how can we enumerate its corresponding states using this notation here? That's what we'll do today. Okay. And make sure you understand about possibility, partial completion, etc. Right? That's definitely useful for going through the material today. All right. Basically, that's it. Do you guys have any question about this particular notation here before I move on? We definitely need that for today. Robbie. Yeah, about the data sheets or cheat sheets. What's your guys' thought? Or you have no preference? I can tell you what the difference might be. If you guys are allowed the cheat sheets, in that case, I wouldn't ask questions more related to definitions. On the other hand, if you guys don't have any cheat sheets, I might ask some simple question about definitions. In which case, for the critical concept, if you know about the definition, you can also get the marks. Do you guys have any strong opinion? Like you think there should be cheat sheets or not? If no strong opinion, I will decide for you guys. Any strong opinion? You can speak up if you want to. I have no strong opinion, but when will you tell us if we can? I'll tell you right away. Any opinion? How about no cheat sheets? That's what I thought. All right, how about that? Okay. No cheat sheet. However, you don't need to memorize the algorithm, especially for the parsing. If I ever ask you questions related to parsing, I'm going to put it in appendix. That's something you don't need to memorize. However, for other critical actions, like how to, I'll talk a little bit more, maybe on Tuesday. So maybe I wouldn't say too much for now. Okay, but no cheat sheets, confirmed. Okay, good. Thank you. Let's now cover today's topic. Okay. Just before I dive into it, I would like to remind you some very important analogy. Remember, we talked about how you can convert an arbitrary epsilon-NFA into a DFA. And we use a technique called epsilon closure and also subset construction, and also lazy evaluation. We're going to do something very similar today on the LR1 item. Okay, let me just remind you very quickly about a critical thing you should really know. So let's say you have some input epsilon-NFA. I'll just draw that just for conceptual reminding. So let's say if you got, let's say Q0. You have some epsilon transition, maybe you have some other thing, maybe 0, and etc. Okay? there would be some corresponding output DFA. And if you remember the corresponding one over here, especially this state, do you guys remember how to calculate the corresponding state for the DFA, just for this one here? Do you guys remember? That's something that will be very helpful for today. Anyone remember? We cannot just put this guy here, right? Directly. Not necessarily true in general. Robbie? You got to calculate epsilon closure? Absolutely. Okay, so two things I want to say. One thing is already mentioned by Robbie. You definitely want to calculate the E-close of Q0. And that one there is going to be a set of states. And this set over here is going to be used as the initial states. And of course, I'm going to remind you with the table that you used to see earlier. So two things I wanted to remind you, which we'll definitely see today. One thing is about the concept of closure. And the second thing is the concept about subset state. These are the two things you will need to somehow draw some analogy to today. All right, let's take a look. Just that's enough about reminding you what you did before, and that will definitely help for today. Let me move on to the slides. And what we spoke about last time, if you're given some grammar, you can definitely enumerate all the 33 items, right, including initial and final state. And today, we're actually going to talk about, first of all, there is a term you need to know. It's called Canonical Collection, or CC for short. Okay? Let me show you some example right away. Before that, what's really the definition for Canonical Collection? Let's draw an analogy right away. Canonical collection is a set. Every member in the canonical collection is itself a subset. It's more like a subset states that we just reminded you about. So CC0, CC1, CC2, and etc. Each one of them is a subset state, so-called. How would it look like? Let's take a look at some example right away. And these are all the example subset states. For example, you can take a look at, this one may be a little bit small. But if you look at that one there actually is a big set, right? Over here, each individual item there is an LR1 item. So each member in the canonical collection is a set of LR1 items. Okay? That's number one to remember. That's something we will have to manipulate today. And of course here, this particular member in the canonical collection, like a member number 11. Remember, we're starting with 0. That one there has just a singleton set, just one single LR1 item. Okay? But it could be multiple because it's a set. Okay? Just remember that. Let's go back to definition. And let's go over some very simple property based on this definition. It's a valid subset state of LR1 parser. And each one of them is a set of LR1 items, as I just showed to you. And then this will be, remember that's power set notation. Basically, we're saying that the CC you have will be all the reachable subset states you can have from the initial state of the parser. Right? It's like all the reachable states from the input epsilon-NFA. Similar idea. And what will be the maximum cardinality of CC? Is a quick check, given what we have said so far. Maximum, not necessarily reaching there all the time. Well, let's say this. If you have, let's say, 5 members, that's possible. Each one of them is an R1 item. What are the possible set of subsets? What's the maximum cardinality? How do we compute its size? You guys remember? Swap, you say yes. Let's say we got 5 possible states. How many possible subset states do we have, maximum? 32? Yes, 2 to the power of 5, exactly. So let's just remember this formula. It will be 2 to the power of how many R1 items you have. Very good, okay? But like how we did a lazy evaluation earlier, you don't necessarily have to reach this many. So it only depends on how the lazy evaluation will lead you to. All right, so here, so that's an analogy I talked about, and we're going to go to the manipulation very soon. So you can think about all the, each set of LR1 item, the set of all LR1 items will be the states for your NFA. That's the input. And the output CC, canonical collection, will just be all the subset states, similar to the DFA. Okay? Are we okay so far? It's just a definition. And we're going to see how we can manipulate this, right? And the first algorithm we're going to learn, we'll do one algorithm before the break and another one after the break. So we're going to do two today. The first algorithm is something called closure. And this closure here is kind of similar to the epsilon closure. Idea is similar. Given some single starting point, you may have to reach out to certain other multiple points that are reachable, right? And the closure is like an algorithm here. Let's go over line by line. As usual, it's not very long and pretty much symbolic in the algorithm itself. So that's why we're going to do example and do this one. Okay? And once you see the slide, you will see line by line explanation as well. But let's now take a look to see how we can understand this. Okay? Let's take a look. Okay, let's see this, the closure. Let me just go over that line by line. And then we can draw, again, analogy to how you perform the subset construction, okay? So the closure algorithm over here, we are given some input grammar, usually. And you're also given a set of LR1 items, okay? So this will be a set. This will be the starting point. And what you want to really calculate as output will be a set of LR1 items as well. That's kind of close within the starting point, okay? Let's now take a look. Right, we got very short over here. And this one here, as usual, we run a while loop until we actually until we reach a stable point where nothing new can be added, right, to the set. So you can see here, I'll just put some remark over here. So that means you want to keep growing the output set S until nothing new can be added. All right, that's the condition for the loop. Okay, let's now take a look at 1, 2, and 3. We got these 3 lines. That means we have some combination to figure out. But let me go over that, make some remark, and then we'll do example. Okay. And the first one over here, we need to find out in the existing set, we want to find out all the LR1 item of this particular form. Okay? For every LR1 item over there, you can see we got some production rule over here. And then we have the bullet point here. And also we got these two are the components you have to match by the pattern. And this one over here will be the look ahead symbol. Find each one of them. Okay? And let's try to understand a little bit about this item over here. How do we interpret that? Okay? If you look at this one here particularly, let's take a look. This one here, number one, what has been recognized already? According to this rule, and of course, you want to see where the bullet point is. What has been recognized? What? Delta, C, or something else? Anyone? This form here. What has been recognized? Dot, dot, dot. Which means as long as you can recognize something there, could be epsilon sometimes. Okay? So what has been recognized will be just dot, dot, dot. Okay? And number two, what is expected to be recognized next? Recognized next. And this one should be easy to answer. What would that be? Should be to the right of the bullet point, right? Which will be just C over here. So far we have identified the two critical components. One will be the dot, 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 another one will be the C. And the delta simply just occur after the C, okay? That means after recognizing C, if you want to reduce back to A, you need to also recognize delta, right? That one's easy. just according to definition. And also we got a look-ahead symbol. That's where we are. Okay, that's what we have to recognize first. And then for this particular variable c, we want to do something about it. This c over here. This is what's to be recognized next. We want to somehow find different alternatives to somehow rewrite it. And to really find it, we need to find all the production rule, which will start with c. So that's why the c here is going to correspond to the c over here. Find all the possible way to really reduce back to c. Okay, so let me put it here. All the alternative for reducing to c. Okay, we'll do example right after we go through the algorithm. And then after this, we also want to find out the new look ahead. Okay, let me leave this part over here. I'm going to put some remark a little bit later to explain why it should be delta A. But let's take a look at this. This one here. The S over here, the initial set, is going to be expanded by a new set. And the new set just contains a single LR1 item. Okay, let's take a look. And this one over here, if you take a look, it looks like this. C produces gamma and then B. So this will be the new item to add to the closure. The new LR1 item to be added to the closure, which we want to calculate. Okay, and let's see a little bit more over here. And if you remember what we just remarked over here, because we know C would be the next one to be recognized in our parsing. So we want to find all the alternative rule for reducing back to C. For each one of them, we're going to start from just the beginning. Okay, and then the look ahead symbol over here will be something you have to think a little bit more. Okay, I'm going to put some notes over here. Once we have gone through the some example, hopefully that'll be clearer to you. Okay, so B here, according to the definition for the algorithm here, so the B will be a member of the first of delta A. Let's take a look at this very quickly. Okay, why delta A? If you go back to the original item that we are trying to match, you will see after recognizing C, we might just want to see delta, right? So in some way, delta potentially is the follow of C. So that's why when you actually want to add this particular item over here, the look ahead has to be updated. Okay? And then here, delta over here and A. Here's a question for you guys if you're following still. Why do we have to say delta A rather than just delta? It's an important question here. Question. Why not B is a member of the first of just delta? Why do we have to say delta A rather than delta? Given that what we really expect to see after this C is just delta. So why do we have to worry about A? That's an important question. Okay? Of course, you can definitely take some time to think about after class. But in case any one of you have some thought, why does it have to be delta A rather than just delta? It has to do with some condition that we said before. Remember when we calculate the first set and the follow set, we always talk about something that might be, William. Absolutely. That's exactly the point. Good. Good guess. Well, unless you guess. Maybe you didn't guess. Okay, very good. Why not just okay? It's because delta might be knowable. So in the case where delta is actually epsilon, in case epsilon is in the first of delta, in that case, you don't have anything here. So that's why A will still remain to be the look ahead for the new item. All right, okay? It's a very abstract algorithm, I agree. So I just want to go over with you every step, at least you know what's really involved. So when we look at the example, you can see how to calculate it, okay? And before we try to go over some example, let me just draw some analogy here very quickly, okay? What we're going to do is like this. We'll start with maybe some set over here. You can think about this will be the starting set. Hey, if you remember, this is the table that we used to do when we want to construct the transition table, right? For the epsilon-NFA, when we want to convert epsilon-NFA into DFA. So this will be some starting set. And do you guys remember how to calculate, for example, here? How do we make a transition from here to here, right? You somehow have to say, what will be the resulting state from Q0 taking D? And what will be also the resulting state from Q1 taking D? And then take the epsilon closure, right? That's what we used to do. So that's something we'll definitely see. So I'm going to include this table over here. For many of the computation we're going to do, they somehow correspond to this. Maybe that's something I can also wrap up on Tuesday. Okay? Let's now do some example, and then we'll take a break. So this example will take some time to really do. So here is the question. CC is the canonical set. Okay, so this CC here is the set of subset states. Okay, and then each subset states is actually itself a set of LR1 items. All right, just keep that in mind. All right, so we are now given this particular grammar, and then this is the algorithm we just kind of briefly walk through. And what we want to calculate is the initial subset states. So this is the initial subset states for the parser. Subset states of the parser. Eventually, we're going to show you how you can calculate the DFA for the parser itself. It's just a finite state machine. So think about what's going to happen is the parser is going to start with an initial states, which is CC0. Okay? And after the break, we're going to see, given this particular CC0 as the initial state, what if we take some transition? For example, what if we have red opening parenthesis? What's going to be the corresponding subset states? That's what we'll do after the break. For now, we'll see how to compute this one to begin with. Okay? That's our roadmap to show to you. And whenever you see this kind of question, how do you calculate the initial subset state? How would you do it? Okay? You want to find out what's the initial state first and find its closure. That's what you did when you did the epsilon-NFA to DFA conversion. So that's why I put some hints over here. Let's go over it together. We're going to calculate the closure, which we just went over how to do it, of the parser's initial states. What's the parser's initial states? Do you remember? Isn't that something we just learned last time? Let me just find that for you. Right, over here. Initial state. So this will be where we start from. Okay? So what we want to do now is, let me write it down. So here we got parser's initial states. Is, okay, here you can see this will be the starting rule. It's going to be the goal produces nothing has been recognized as the initial states, and then the list. And the look ahead will just be EOF. That's something we said last time, right? So this will be the starting initial state. And then in order to calculate its closure, we have to convert this initial state into an input. Every input to the closure should be a set. Okay? And we're just going to put some symbol here. It's going to be a singleton set. Okay? So this will be the input to the closure. It's pretty much like, if you remember what we did before. Think about if I got some epsilon-NFA, and then I actually got Q0, let's say. So what should I do? What I need to do is if I want to calculate the corresponding DFA, I need to find out all the epsilon closure of Q0. That's exactly what we're doing. Okay? E close of Q0. Think about the closure here is similar to the E close that we did earlier. Okay? And let's do it. Okay? And it's an iterative algorithm, so you have to really keep doing it until you cannot make any progress. In this way, I can tell you we need 4 iterations. Okay? But once we get through the first one very carefully, others wouldn't be too bad. Okay? Let's now take a look. Okay, give you some look ahead. We got step number 1, 2, 3, and 4. 4 iterations. Okay? But every step is going to follow similar hints just to help you out how to really instantiate the algorithm that we just spoke about. Right? I really try to keep it as organized as possible. And eventually, this will be the result we're going to get eventually. I'm going to show you the progress. We start with this particular item only. We only start with this. And then eventually we're going to expand the resulting closure by 1, 2, 3, 4, 5, 6, 7, 8. 8 members into the set. And we're going to see exactly how to do that. Okay? And the convention will be, whenever you see gray, so that means that's the set we already got from the previous iteration. And initially, we just start with this. The green ones are the ones we're going to get newly in the current iteration. Right? That's what you will see. Let's take a look. Okay? It's not too bad. Okay, we'll start with this. I just named that as 0. Okay? So this will be the initial parser state. We'll start with that. Right? You can see this one here corresponds to this over here. What we have to do is we got to do some pattern matching. Remember this one here? That's why I put it over here. You want to match what A is, what beta is, what C is, what delta is, and what A is. That'll make it just so much simpler for later calculation. I'll let you guys stare at between this one here and this one here and tell me what A, beta, C, delta, A are individually. Let's go step by step. Okay? Okay? Farden, what's A? If you try to match. Can you see what A is? Well, this is the produced sign, right? A is whatever that goes to the left of the arrow. So what will be A in this case? The goal. Yeah, as simple as that. Don't hesitate. It's easy, right? It's not difficult. All right, that's the goal. All right, the next one. Jifen, do you mind? Beta. Beta, I'll give you a little bit hints. Beta here should be whatever that goes between the arrow and the bullet point. Epsilon, absolutely. Nothing here at the moment. Yes, absolutely. All right. Hopefully you guys got into it. And what about C? Jordan, what's C? Absolutely. C is the first component that goes after the bullet point, right? So guys, it's really important for you to match that. So that's why I'm trying to pointing you guys out. Make sure you're fine, right? So C here will just be the list. Okay? 2 more. UU. What's delta? Delta is whatever that's between the first components and the comma. Empty. Yeah, the first component C is already, we know, is a list. And what's between the list and the comma? Nothing. Epsilon, right? Absolutely. Epsilon. And finally, I can do this. This one is too simple. A will be just EOF. Are you guys okay? If you got anything like this in the exam, I would suggest do this step first. That will just make it much clearer for you why you should really compute. So what we just did was just to match this line over here. All right? And if your current set contain multiple rules, In that case, you have to match multiple times, but we only choose one at a time for each iteration. Okay, for now, we have no choice. This is the only one that's in the set. All right. And hint number 2, we have to go on to the second for loop. Given that the C here, let's see where C is. C is the list over here, right? So that means we want to find out all the production rule related to C. That's what we got to do, right? So you can see production rule corresponding to C, corresponding to list will be this one here and this one here. So we got 2. So that means we need 2 additional items for this iteration, 2. All right? Keep that in mind, and I'm going to write it down. So there are 2. So one will be the list produces the list followed by pair, and also the list produces pair. Okay? You got 1 here. Oh, you know what? Yeah, just got 1 here, and also you got 1 here. 2. Final one, we want to somehow calculate the first of delta A, which will give us the range of the look ahead symbol for the new item. Okay? Let's be very careful here. We know delta here is epsilon, right? So it's going to be the first of epsilon, right, which is delta, and also A, which is EOF, which will be just the first of EOF, which will be just EOF. Are you guys okay? Right? We'll see some different calculation next in the later iteration. Now we got everything you need. All we got to do now is to put the combination between this row over here and the B over here. Okay? For the first one, I'm going to do it together with you. I'm going to do it, and then for the later one, I'm going to point to somebody to help. Okay? So just really push you to get as much as possible just from today. Okay? So we will have 2 new LR1 items. Number 1 is going to be based on this. So it's going to be the list produces, right? You can see we should put the bullet point in the beginning. So which will be here or in the beginning here, right? So it's going to be bullet points, and then the list, and then pair. And the only choice of the look ahead symbol B is just EOF. So we just put EOF over here. That's the first one. Okay? And what about second one? So let's go for this one here. So it's going to be the list produces bullet point and then pair, and then EOF. Mechanically, make sure you're okay. I'll give you a little bit of explanation about intuition, why we're doing this. Okay? You can think about this. When you are first trying to match strings acceptable by this particular grammar, the grammar is going to accept things like maybe parentheses, or maybe nested parentheses, or a list of nested parentheses like that. So we are saying that, what can you expect in the beginning? After the current calculation, we got either this, or this, or this. That's what we have calculated. You can be just in the beginning of some list. You can be in the beginning of some pair. You can also be in the beginning of some list followed by pair. So these are all the possible inputs you may face ultimately. If you only got this one to start with, that's not enough. It cannot really accommodate for all the possibilities for the input. That's why we have to calculate the closure. Okay? That's the intuition. Guys, any question? The rest before the break will be to do this 3 more times. Okay? Let's see. And there's one more thing I want to mention, but let me move on to the next page. Okay? And what can you expect in the next page? So once we are done with the first iteration, you can think about the closure set S in the algorithm now contains not just the initial one we start with, but also 2 additional items. That's how we're going to start with. Okay? Let's now do that. That will be the start for iteration 2. So that's the initial one. So these were the 2 additional ones we added in the previous iteration. Right? Now, in the actual exam, you have a choice. You can either try to find to do the pattern matching, especially this guy here, you can either try to match this one to number 1, or you can match this one to number 2. The order doesn't really matter. Ultimately, you're going to reach that fixed point anyway, so the order doesn't quite matter. For now, I'm just choosing the order that's easier for me to present. Okay? Now, let's say we choose this one to match. Okay, similar exercise. Okay? And to save time, I'm going to call a single person to tell me if we choose this one here to match, what would be the corresponding A, beta, C, delta A? Well, somebody would like to volunteer. Robbie, good. Just before you do that, let me just get ready. We want to find out what A is, what beta is, what C is, what delta is, and what A is. Robbie, what's A? Will be a list. I agree. What about beta? Epsilon, absolutely. Because nothing before the bullet point. Very good. What about C? Pair, I also agree. What about delta? Epsilon, absolutely. What about, look ahead? NO5, EOF, absolutely. Thank you. Yeah, this one's also easy. We'll see a little bit different pattern matching in the next iteration or so. Okay? And now, what rules should we find? We should find what C is. You can see C is actually the pair. So that means we should really find out all the production rule related to C, the pair. So now we got this one here. Okay, let me write it down. And since we got 2 alternatives, we got 2 more additional items to add, right? Let's see. So this will be, let me put it here. It will be pair produces pair this. And also pair produces this. So these are the 2. Okay? And Matthew, would you like to try? What's delta A in this case, first of all? Let's start, what will be the concatenation of delta followed by A, given that what Robbie just said was actually right? Yeah, so epsilon, yeah, absolutely, thank you. Epsilon and the file. And what do you think this would be in this case? What's the first of this? But remember, epsilon actually has no effects in the string concatenation. So this will be as if you say, yeah, very good. Yeah, this is what you will have to do in the exam. Better make sure you make some mistake now rather than later. So this will be just EOF. The same as before. Okay? So we got all the hints we need to know. And then how do we enumerate all the new items over here? Okay? Okay, so let me find someone. Colin, would you like to try? So we know that eventually we need 2 new items to be expanded into S. And given all these we have, do you think you know which 2 precisely we need to add? If you want to skip, you can skip. That's okay. Okay, sure. So there's going to be 2 items. Let me put them first. How about the first one? Yes, go ahead. What would be the production rule, the first part? Absolutely. First of all, just make sure you guys know. So in the beginning, right, and that's a production rule. We're just adding bullet point here. And that's corresponding to exactly this. Okay. What about the A, the look ahead? Sorry, the B here. In a file, absolutely. What about the second one? Dot, bracket, and then and a file. Yes, easy. Okay. We will see something a little bit different in the next iteration. But second one, we also know how to do it. So that's why when you see the notes, you will see that these were the 3 we got from the previous iteration. And in this current iteration, we just added these 2. And knowing what's going to be ultimately the size of this exact closure, we got 1, 2, 3, 4 more to go. Of course, in the exam, don't get me wrong. In the exam, you don't really get this one as a hint. You don't really get it. Otherwise, what's the point of calculating? You just copy that, right? I'll make sure I don't give that to you in the exam, okay? All right, good. Third iteration, okay? Now for the third iteration, so we actually got these were, okay, let me recap. This is how we started with. These two were from the first iteration. These two were from the second iteration. Okay, we're gonna go for more. And now you have a choice. You have to choose from each one of them, or any one of them to do the pattern matching. Okay, let's say I choose number 1. Why? It's just arbitrary. In the exam, you can choose in any order you like, as long as you can make some new addition. If you believe that out of all the choices you can make, you cannot really expand S anymore, that means you reach a fixed point. Then that's the point to stop and terminate. Okay? Let's say we find number 1. All right, so far I haven't asked any girls. Why don't we try? Okay? I'll let you girls work together and I just need the answer. Okay? Let's say we choose this rule over here. Okay? Hint number 1. What should we match? A, beta, C, delta, and A. Any one of you. A, beta, C, delta, and A. Of course, if you really don't want to answer, you can say pass, right? Monica, Qingyi, or A is list, I agree. Beta epsilon, because nothing in between, I agree. What about C? Now it's a little bit different, right? Don't think epsilon is always, don't think delta is always epsilon. It's not, right? That's why I gotta finish everything, okay? Think, what should be C and what should be delta? This might be a good time to just remind you. C will be the first components. Delta will be the remaining components. What's C? List, I agree. What's delta? Pair, yeah. And what's A? In a file, also. All right, that's good. Okay. And now that we know what C is simply just a list. So when we want to find out all the alternatives, we should really go for the list. Again, we're back to this rule. So you may have to refer to the same rule multiple times. You may have to. All right. And first question right away. How many more additional items do we need for this iteration to add to S? 2, right? 1 based on here and 1 based on here. Actually, not necessarily, because it's going to be a combination of how many alternatives you have for C and also how many first you have for delta A. So not necessarily just the number of this, but we'll see. Okay, so here, what about first of delta A? Yes, so since you answered the previous one, why don't you represent them? What's delta A in this case? It's going to be the first of what's delta and what's A. Let's start with that. Delta is over here, which is pair, right? Okay, and what's A? And a file. Okay, very good. Now, this is slightly different from what we did before. This is slightly more complicated, right? Okay, now, how do we compute this? Of course, in the exam, you will need to have the knowledge about computing the extended first set, which we spoke about earlier. Make sure you review that. In this case, let me just do that intuitively with you, right? Anyone know the answer, first of all? What should that be? Should it be EOF? By the way, it would be EOF will only be there if pair itself is nullable, right? Is pair nullable? Is the first of pair nullable? No, it's not. Let me put a side condition here just to remind you. The epsilon is not a member of the first of pair. It's not. Okay, just remember that. So now what should be the first of pair? Japan, if you don't mind. Yeah, opening you meant. Not follow. Actually, even follow is not right. Okay, first. Okay, be careful. Yeah, good. That's all right. Okay, just this. Okay, just that. Okay, we are lucky. There are two alternatives over here and one first symbol here. So 2 times 1, just 2. Okay, good. So let's now write it down. Okay, for this one, I'm not going to trouble you. Let's do, let me just write it out. You can tell me if you don't agree. It's going to be, first of all, start this one here. List produces in the beginning, list, and then pair. And then there's only one possibility for B, which is closing parenthesis. And the second one will be the other alternative, which will be pair. So that will be the list produces in the beginning, pair, and then closing parenthesis. These are the two new ones, right? Again, so if you look at the notes, you will see these are the additional ones we have just made. We just added to the S. Okay, we got 2 more. All right. Why don't we, for completeness, let's finish that. Okay, gonna be quick. So far, we got how many? 1, 2, 3, 4, 5, 6, 7. We got 2 more. So in the exam, I might just give you another set to actually compute. And when should you stop? When you actually cannot make any progress. That's when you stop. Okay. Final step. Okay. So again, this is from the first. That's how we started with. First iteration, second iteration, and third iteration. Let's say we choose number 6. Magically, once you compute this one here for the iteration here, we're going to reach a fixed point, and we don't have to go on anymore magically. Of course, you're going to decide that magical moment on the exam. Okay, let's now do this one. Okay, let's see who I haven't really consulted with so far. Nicholas, I'm pretty sure you're keen to be consulted. Okay. Okay, so let's say we do this one here. And again, A, beta, C, delta, and A, please. Absolutely. Opening parentheses, absolutely. And then, accordingly, we know that C is the pair. So we're going to match all the alternative for C, which is pair. Oh, sorry. You see, you got to be careful. Pair over here. Okay, good. And what's delta A? It's going to be the first of, what's delta A in this case? Let me write it down first. It's going to be epsilon, and then oh, sorry. What am I doing? Sorry, just got myself confused. This is capital A, little a here. Okay, good. And what is that? Yeah, no epsilon, right? Yeah, just make sure. Good, because that one has no effect on the concatenation. Okay? That'll be just that. Good. And I need someone to help us finish this example, and we can take a break. Okay? Qingyi, go ahead. Which 2? What should I write here? 2 additional LR1 items. Given what we have said about each hints, what should they be? Number 1 and number 2. I should cover these 2, so you cannot see that. Sorry, say it again. The pair, okay. So I'm going to write it down, okay. So 2 here. Pair. Pair, can you speak a little bit louder, please? Dot. And then open parenthesis. Okay, maybe Monica, you can help her. Opening bracket and. And what should be the look ahead symbol? Yes, absolutely. Exactly here. And second one, please. Dot. Absolutely, right? Yeah, guys, just be mechanical on this, but I already also mentioned about the intuition behind. And make sure you can do stuff like that, right? It's complete, the solution to this, all right? Let's take a break for 5 minutes, and then we got one more small algorithm to go through, and then we're done for today, all right? Take a 5 minutes break. 3:30, come back. Boom, boom, boom. All right, guys, 3 minutes. All right, 2 minutes. How many have we got so far?
9.
Only 9?
There are not enough remaining classes.
Then there are 2 resolutions to that. Either the assumption is false, so in that case, I can choose not to give any participation mark, or I can just based on what we got. Yeah, I know your point. I know your point. Yeah, it's too bad. Really 9 so far. I thought we got more, to be honest. Only 9? Oh, okay. Oh, could be. Yeah. I think you guys, but I think almost everybody's here all the time, right? So I think, yeah. Only 9. Okay. Yeah. Yeah. No, I didn't take. No, not today. Don't worry. Yeah, guys, don't worry. Based on what we have got so far, if you got 90% or more, you got 5%. No trick. No trick.
Did you ever find the additional person who filled out this evaluation?
Okay. Hey, why don't we take a look? Yeah, yeah. Yeah, guys, I think we should really get started. But before that, let's answer Matthew's question, which I'm pretty sure you guys got questioned as well. I think I really meant to keep you guys posted after the class, but let's take a look at the course evaluation site. Give me a moment. Yeah, so I think you guys did pretty good. So I think after the final reminder, we did reach past that 85%, which is good. So that's 0.5%, right? Huh?
What if Matt's one of those people? We should add one more just to,
Well, you know, it's like that threshold is supposed to be like, was it 10 p.m. on Monday or something like that, right? But this one was, maybe that's okay. I'm going to give you guys the 0.5, even though that's reached a little bit later. Right? Okay? Guys, don't worry, assume. I'm going to apply that 0.5 to everybody. No problem. Okay? If I say that, I'll keep that word. So that means if you have been coming to the class and did, you would have got 5.5%. That's good.
What happens to your 46 classes?
It's in the winter. It's in the winter. But you see, for the 2030 here, it's too bad. I really wanted to give to them, but it's not there just yet. Yeah. In some way, that's also good, right? I don't need to be worried about grade anomaly later. Yeah. Okay, good.
What class is 4350?
It's a mission critical system. Yeah. Good. That am my first time. Yeah. Usually it's. I'm not sure if you've been taught by him, Frank. Okay. Anyway. All right, guys. Let's now continue. Remaining part will take about only 10 minutes, but let's focus, and then we're done. Okay. Okay, so before the break, we talk about closure, okay? And let's now talk about another very logical follow-up to the closure, okay? Think about what's happening here. Before the break, we talk about, let's say, if you can calculate the CC0, which is the initial subset state for the parser. And now we want to know what's going to be the corresponding states if we try to read some symbol, like a shift operation, right? That's what we want to do. And the algorithm that we need to look at is called Goto. That's the algorithm. So for today, basically we learned about closure, we learned about Goto. Next week, the last class, I'll make sure within 1 hour, I'm going to combine everything together so you'll see how to build the action and the Goto table for the bottom-up parsing. And then we are done for the course, okay? Good. So this one here, don't worry, you can see only a few lines of code. Pretty easy, okay? I could have asked you guys just study by yourself. I'm pretty sure you can get it, but let's save some time. 10 minutes, okay? And the algorithm is going to be something like this. It's going to be a set of LR1 items. You can think about this one here should really represent the input or source subset state. Source subset states. And the output over here is just another subset state. That will be the target. So this will be the target subset states. And over here, we got some symbol X. So what does that mean? That means if you got the input over here, subset state, you got the output subset state, they are related to by X. As easy as that, okay? Let's see how we can compute it. And the way we're going to do that will be very similar to how you construct the transition table for DFA. Let me just remind you the steps. I think I mentioned that very briefly before the break. Let's say how do I compute to say I go from the initial state by taking, let's say, D, some digits. I need to compute. Okay, let me just remind you. Let's say this is the source. And how do I compute the target? And of course, this will be the symbol X, the input. So how do we relate them together? Let's remind you very quickly. So that means you have to somehow to do delta, the normal transition from every member there. So that'll be Q0, and then take a digits. And also union with the delta of another member here, Q1, also taking D. And once you got this one here, you're going to take the closure. That's exactly what we're going to do for this. Okay, so let's look at the algorithm. And I need some help from you guys to help me interpret before I tell you. Okay, and I can help you here. We're going to have a set called moved. Okay, and then we're going to find all the item which has this particular pattern. And then we're going to extend the moved, meaning the target state, by this new item. So what I want you guys to do is to compare this one here, what we can match, and this one here, what we can add. Can you tell me how are they related, the green and the pink? And by the way, they're different. If you think they are the same, no. Look closely, especially where the bullet points are. You thought that they were the same? No, they're not the same. No. Okay, yeah. Okay, good. Yeah. Good. So now, how is the green related to the pink? That's the question. Okay, anybody try to put intuitive term? That's the essence for the algorithm. Once we know it, we're going to do one example, and we're done. Okay. How are they related? Of course, watch out the difference, right? How the bullet point has been moved from one to another. For those of you who still are not convinced they are different, take a look here. Now you're convinced, right? I'm pretty sure. If you they switch, yes. Yeah. You know what? Actually, that's what happened to some of your classmates from the winter. Right? They said, "Oh, are they really different?" I said, "Here." They said, "So what?" I said, "Oh yeah, they're different." Right? Yeah. Anyway, that's. I think that person is doing well. He graduated, which is good. All right, anybody want to try? Just intuition. Don't worry about being wrong. Jordan, I'm pretty sure you want to try. Let me help you a little bit. I can see where you're going. How about this? For the first one here, we have already read beta. We're expecting to read X. Haven't read it yet. How about pink? Oh, no, you're thinking too complicated. Way too complicated. Let William help you. Yes, go ahead, William. Yeah, exactly. Yeah, I agree. Yeah, good. Let me put it down, just to, in case. So this one here, you can think about expecting to read X. Expecting to read X. And this part over here is you have already, X already recognized. Okay, so basically what we're going to do is, since you're trying to take some transition, we'll take a shift operation more specifically. So that means in the target state, from here to here, you have the only difference is you have read X, right? That's it. Okay, so let's now try to do one example. Right, sorry, I forgot some very important point. Once you have calculated the move over here, afterwards you have to calculate the closure. Just make sure any possible expansion will still be taken care of. Pretty much like the E-close over here. All right, that's why analogy is really important in this case. Let's try. Okay, so you will see on this, excuse me, you will see on the slides the example you can do is this. You can definitely try, but I'm going to go over with you anyway. you're going to calculate the Goto. Okay, that's the algorithm. So we start with initial set CC0. It can be any arbitrary I might give to you in the exam. And some symbol. Let the symbol be opening parenthesis, which means we want to shift by just reading the opening parenthesis. And what will be the corresponding target subset state? Okay, let's see. And let's look at the relevant information here. CC0 is what we calculated before the break. There are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 members there, right? That's a starting point. And that's the go-to algorithm we just did. And then this will be the final result, but let's not look at that just yet. Okay? How do we compute it? Let's be careful. First of all, can you guys stare at that input over there because you got to practice? How many items there can match this pattern here? The pattern goes very specific. After the bullet point, it must be a symbol. It cannot be a variable. So that means you are now at a state of the parser where you are expecting to read a single symbol, not a variable. Okay, let me just put it down. You guys can tell me exactly which ones are the ones to match. X over here must be a terminal. Okay, can you tell me how many will match this pattern here? How many? We can go one by one. Oh, Willie, you want to say how many? 4. Okay, remember that number. Okay. Would this match? No, because after the bullet point, it's a variable. No. Would this match? No. It's a variable. Would this match? Yes. So I'm going to highlight it in green. Okay, how about this one here? Does it match? No, because it's a variable, right? Would this match? Also no. Would this match? Yes, it's an opening parenthesis. Okay, and would this match? No. Would this match? Yes. Good. You guys tend to agree. Thank you. And what about the final one? Would this match? Also yes. Absolutely. So before we get to the closure phase, we'll do that at the end. We want to basically shift the bullet point for each one of them. Okay, let's now do that. Okay. Let me be very precise for you. So here we got 4. So let me write it down here. So pair produces this. Pair. That. And also we got, I'm going to do some copy and paste, but I just want to make sure it's complete to you when you study for that. And also the second one, EOF. And number 3, we got pair, bullet point, pair, EOF. And the fourth one will be just pair produces. Okay, these are the 4. And now I'm just going to do something that you guys cannot really do on the exam. Okay, first of all, like that. And then they will correspond to this part over here, right? Again, if you look at the difference, as William said before, X will now become to the left of the bullet point. Okay, let's now do that. I'm just going to paste it over here, and then I'm going to change its color just to blue. Right, you can see this color is matching this, right? Except I got to move the bullet point. Here, 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 and here. Okay, are we good? Okay, at least it's clear to you. Okay, that's the blue one. And what's more, we got to calculate closure. Basically, this will be the input for the closure. Okay? And we want to calculate the closure. And I missed something here. Okay, so for this one here, we want to calculate the closure. And if you try to recall briefly, in order to calculate the closure, we need some kind of like a variable, right? In order to get some additional items. So it turns out only these two can actually, these two will actually will be the additional items we have to add. Only if after the bullet point you actually got a variable will you actually have to worry about having some additional items for the closure. So these are the only two. Okay? I'm going to put down the insight for you. Basically, this one here. And also this one over here. Okay? These two will trigger additional items. Okay? And quick exercise for you. Okay? I want you to look at these two. This one here and this one over here. Once you calculate the closure, you're actually going to get this one here and this one here. Okay? That'll be some exercise for you to think about. I will review this again on Tuesday. Okay? I'll put down an exercise and then I'll say something a little bit more and then we're done. Okay? So here, exercise. Okay, exercise. Why the highlighted items trigger the two additional items. Right? You want to definitely, in order to answer this, basically relating these two to these two. To answer that, you want to go back to where we talked about before the break of this particular algorithm. Right? Something for you to think about. I'm going to recap this part here by using that on Tuesday. And for Tuesday, we got the final part to really finish off the bottom-up parsing, which is about how to build the actual go-to and action table. And that's it. But I would suggest don't really wait until Tuesday to actually say start reviewing the material. You should really start right away, right? The exam next Saturday, pretty soon. All right. All right, guys. Thank you, and I'll see you next time. Have a good weekend, and don't forget, project is due on Tuesday. All right.